All right, so let's do an example. So consider the point 234 in Cartesian, and say we want to convert that to spherical coordinates. So basically what we would do is we just remember our equations that we derived previously. So we know that x is going to be equal to rho sine phi cosine theta. Y is equal to rho sine phi sine theta. And z is going to be equal to rho cosine phi. Right? So, and also, rho itself is going to be equal to x squared plus y squared plus c squared, square root of that, right? So basically, if you have an exam or something on this, there's really no way, unless you feel like deriving it and taking like at least 5 or 10 minutes to derive that. If you forget it, there's really no way of not just memorizing these, and it's a lot easier to do so. But anyway, it's always good to know where they come from. So, all right, so we know that x is. All right, so x is going to be equal to 2, obviously. Y is going to be equal to 3. These are just random numbers I picked. Z is equal to 4. And so therefore, the first thing we do is calculate rho, right? So rho is going to be equal to the square root of 4 plus 9 plus 16, right? So equal to 29. Square root of 29, right? 16 plus 9 is 25, plus 4, 5 and 4 is 9, so it's 29. So, since rho is the square root of 29, then we can use the fact that z is equal to rho times the cosine of phi, right? We know z already, because we're told z. Z is 4, right? Right here. And we know rho, because we just found it. And so therefore we can solve for phi, right? So then 4, using this equation. Again, this is just plug and chug, really, if you can, when it gets down to it. 4 is going to be equal to rho, square root of 29, times the cosine of phi, whatever that is, right? So we'll divide both sides by the square root of 29, right? So we get, and then obviously take the inverse cosine, so I'm skipping 2 steps here. So we get phi is going to be equal to the arc cosine of 4 over the square root of 29. And I didn't choose my numbers correctly because that's not really a great number to take the arc cosine of, because it's obviously not rational. And if I can find my calculator, way to be prepared here. Just had a second. Oh, here it is. So what is the arc cosine of 4 over the square root of 29? Arc cosine of that. That's in radians and I want it in degrees. So 4 divided by the square root 29. Okay. That's 0.74 something. So then the arc cosine of that is 42 degrees, supposedly. Right, so phi is going to be equal to 42 degrees, right? And yeah, we know rho, obviously. Okay, so now that we know phi, we know rho, then we can either pick x or y, because we know, obviously, x and y. We know rho now. We know phi, so then the only thing that's undefined is theta, and obviously you have one equation, one unknown. You can easily solve for it. So, I don't know, let's just take x, for example. Right, so we know the fact that x is 2, right? So 2 is going to be equal to rho, square root of 29, times the sine of 42 degrees, right? So we still have it in our calculator, so we'll just take the sine of the answer. And that's 0.67 times 0.67, right? times the cosine of theta, which we don't know yet, right? Right, so this is just one big number, so we can easily solve. So then that 0.67 times the square root of 29 is 3.6, then 2 divided by that is 0.55, so then the cosine theta is going to be equal to 0.55, right? So basically what I did was I multiplied these two numbers, and that comes out to 3.6, right? So this is 3.6. Then I take 2, I divide both sides by 3.6, right? This cancels, and then you get that, which is just 0.55. All right. So then we take the arc cosine of both sides, right? So the arc cosine of 0.55, again, this is in degrees, so this is equal to, so theta is equal to 56.6 degrees. Actually, you know, just for the sake of argument, let's just say 57, just to make it easier. 57 degrees, right? So then, therefore, rho, theta, and phi is going to be equal to the square root of 29, right? Comma, theta, which we just calculated is 57 degrees, comma, phi, 42 degrees. All right? So basically, I'm sure on an exam or on a homework problem, you'll get numbers that'll work out really nicely, and you get, like, you know, really nice even numbers like 60 or 90 or something like that. But this three numbers I just picked off the top of my head and felt like converting that into spherical coordinates. So thanks for watching, and we'll see you again in the next video.